If someone was to tell you that 4 plus 5 equaled 9, you'd be very likely to believe them, partially because that's just how maths works, but more importantly because you can see it happening with real objects. The objects that those numbers represent, because maths is more than just numbers. If you've ever been in a physics classroom, you know that these numbers tend towards equations that we can then use to calculate motion and such.
For example, objects on Earth fall at a rate of 9.8 meters per second. Almost. A number which actually defines a real-life occurrence. An object falling.
Humans have actually become so well versed in these ideas, these equations of reality, that they can accurately create simulations of real events. But there's something special about these simulations.
Every time they run, they give the same result, the same occurrence.
4 plus 5 always equals 9. Whereas flipping a coin in real life won't always give you the same result.
Or will it? Nitapak Samson has produced 9 different prototype designs to flip coins reliably, always to the same side. He's not the first to predict the unpredictable, and he won't be the last.
Of course, there's a great difference between building a machine of reliability, letting the equations of reality just take care of it, and accurately determining the final resting position of a roulette ball just as it starts spinning. Which isn't to say that's impossible.
In 2004, a gang of 3 mathematicians and technicians managed to input the roulette's ball's speed and position, then use it in a microcomputer to determine their best bet. They made off with 1.3 million euros, which they were allowed to keep.
So of course, now you must wonder if it's possible to create a supercomputer and powerful enough to predict all of reality ahead of time and decide exactly what decisions we're going to make.
It isn't. There are far too many atoms, collisions, and possibilities for any array of supercomputers to calculate. However, it won't stop people trying.
We've managed to accurately simulate the universe's expansion, simplified evolution, civilization as a whole, and deathly collisions. It's all become so commonplace that at this point in time, some people do it just for fun. People strive to understand how things work, to simplify it down to maths, to physics, and down to numbers. But maths is more than just the numbers summed together. In the same way that a car is more than the sum of the car parts, a computer is more than a bunch of circuit boards, and any story or tale is more than a bunch of letters on a page. So certainly we can simplify this down to numbers, but the numbers aren't alone. It's about what these numbers represent, the tales these numbers tell. Ultimately, maths is more than just numbers.